Good morning, students. I hope all of you are fine today. So, let's start a new chapter in science, which is some natural phenomena, students. So, what do you mean by natural phenomena? A natural phenomena is anything which occurs on its own in nature, students, and it occurs without any kind of human and other interventions. Okay, for example, the weather of a place, fog, storms, winds, volcanic eruptions, cyclones, they all are grouped and categorized into a natural phenomena. Now, students, some natural phenomena can be destructive, such as cyclones, thunderstorms, lightning, and earthquakes. However, there are some ways, students, with which we can protect and prepare ourselves from these natural disasters. Okay? Now, the first natural phenomena is lightning, students. What do you mean by lightning? It is an electric discharge or an electric spark, students, which occurs in nature and it occurs on a major scale. Now, it is caused by the accumulation of charges mainly in the clouds. Now, you must be wondering, what do you mean by charges, students? Charge means these are the electrical impulses which occurs naturally. Okay, now there are two kinds of electrical impulses. One occurs naturally and other occurs by artificially, that is created by us. So students, these can be deadly and it can cause destruction to life and property. Now students, in ancient times, people were not used or not people were unaware of the cause of lightning, that is how lightning occurs, and hence they were scared of it. But nowadays, as science have developed, so scientists have evolved some precautions which can help us to prepare and protect ourselves from these natural phenomena. So the spark, students, that Greeks, okay, so lightning has been first discovered by the Greeks, okay. So they knew that when amber, it is a type of a resin, or you can say a synthetic polymer, and fur, if are rubbed together, then amber can attract light objects like hair. Similarly, if woolen clothes, or you can say polyester clothes, they can also attract hair, and as a result they can produce a little spark or crackling sound when, if you taken off, or if these clothes are taken off from our body. Why it creates a crackling sound? As because of electric charges. Now students, the scientist named Benjamin Franklin, he has discovered in 752 and proved that lightning and spark can be produced from these clothes are all same things. Now the question arises, what are electric charges? Students, as you have learned that an atom is a divisible, that means in atoms there are three subatomic particles, namely electrons, protons, and neutrons. Okay, now protons and neutrons, they are combined and they are located in nucleus, students. So as we have learned that every atom comprises of subatomic particles, so all these particles share a common property, that they carry electric charges. Now electrons, they have a negative charge, while protons, they have a positive charge. Now students, we know that atoms carry a balanced charge. Okay, as a result, all the objects which you can see just beside you, okay, they are all balanced, as because they are not reactive at this point of time. However, charges may sometimes become out of order, and hence the charges flow from one place to another. So an object will be called electrically neutral if it carries a balanced proportion of positive and negative charges. That means in all the objects, all the atoms, they do have balanced positive and negative charges. So an object which is called a charged object if there is an imbalance of electrons and protons in it. So an object possesses a charged object whenever the ratio of electrons the ratio of electrons and protons are varies. Okay, now students, remember one thing, protons cannot flow, okay, as because protons are located in nucleus. Only electrons can either go out of the atom, or else some electrons can flow inside the atom. So hence we can say that electrons revolve around the nucleus. Okay, now how charges arises by rubbing. Now students, when we rub two objects with each other, they get charged due to transfer of electrons between them. For example, if you take a rubber balloon with animal fur, the balloon, which is made up of rubber, it attracts the electrons from the animal fur. Now this results in rubber having an excess of electrons, while fur, they are having shortage of electrons. So in the same way, students, we can rub a plastic comb in our dry hair, and after rubbing the plastic comb, you will see the comb will acquire some charge, and as a result, it will attract some small pieces of paper. Okay. Now, what are the types of charges and their interaction? We know that, students, the charged objects may have a shortage or it do have excess of electrons. So an object which is having an excess of electrons, they are called as negatively charged, while an object they are having a shortage of electrons, they are called as positively charged. Now, if you take a glass rod and it is rubbed with a silk cloth, then it will become positively charged, while the silk cloth becomes negatively charged. Okay, so these charged objects, students, are now capable of attracting some other charged bodies and other uncharged objects. Now objects which are having the same kind of charges, they repel each other, while the objects which are having different kinds of charges, they attract each other. Okay, if you see the pictures, see positive charges and negative charges. In both these cases, the charges are repelling. Now in the third case, see a positive charge and a negative charge, so both of them are attracting. Okay, as because they are opposite charge. All right. Now, what do you mean by electrostatic force, students? It is a force of attraction, or you can say it is a force of repulsion, which can be experienced by charged objects. Okay, so if you see the picture, particle 1 and particle 2, they do have different charges. Okay, there is a positive and negative charge. So as a result, the force of attraction occurs. So this is called as electrostatic force. Now from this, another topic arises, static electric charge. So static, okay, static means which doesn't move. So this electric charge is an electric charge which doesn't move. That is, when two objects are rubbed with each other, then the charges will not flow. How it happens? When two surfaces come in contact with each other repeatedly, it will result in the transfer of electrons from one material to another. Now, the strength of the electric charge depends upon the different factors, students, such as number 1, the humidity and the temperature, and number 2, the material of having the properties. Okay. So in opposite to static charge, there is an electric current. So the electric current results when the charges flow from one point to another. So this electric current results in glowing of bulb or working of all the electrical appliances. See, students, in the picture, that is, the charges are moving from one point to another. So in this way, we can say that it is generating electricity. Now, how does transfer of charges takes place? Charges can transfer from one object to another with the help of two methods. One is the conduction and another one is the induction. So conduction means when a charged object comes in contact with the conductor, then it results in the transfer of charges in the conductor. See, students, in diagram 1, a neutral metal, okay, which is resting upon an insulating platform. Now, when the positive aluminium plate, it is placed near to the metal sphere, then the electrons are drawn off from the sphere and it passes to the aluminium plate. And as a result, aluminium plate loses its charge to the positive charge, and the metal sphere now has an excess of positive charge. On the other hand, the induction, when a charged object is brought near a neutral object, it results in shifting in the position of the electrons in the other object. So The process of induction, students, does not involve any kind of physical contact between the charged and the uncharged object, while the process of conduction requires a physical contact between them, students. Okay? Last topic of today's class, that is how transfer of electric charge leads to conservation of charge, students. See, the net charge on a neutral object is zero, as we know that, so that is why all the objects are electrically neutral. However, when it receives some electrons from another object, then the net negative charge on the first object is equal to the net positive charge of the second object. So in this way, charges are conserved during transfer of charges, students. Okay, students. So students, that's all for today. In our next class, we will continue with the chapter. Okay, students. So thank you for today's class.